In this video, we are going to implement our first code to solve this Gray-Scott differential equation. And let's go ahead and make a file we call naive, because that's what he calls it, naive implementation. All right, so we need to use our constants here. Let's just get all of them. Actually, let's go ahead and put that there. And now we're good to go. All right. So what do we need here? What do we need? So we are making an update function, and it's going to take a UV. So we need to reference that. And let's call it, also it's going to take some update options, which we have in here in main, which I think is going to be not great. Let's grab those and let's go into the library and put them, we'll just put them here. And then we need to patch up main, use Gray-Scott, run options, and now they are available everywhere. This thing does not build. Right, okay, fair enough. So here we have to say use UV build. Still not building. No arc because we need to say use clap. There we go. So what we need now is here we need to say, okay, we have our options, right? So we have our options. Use create update options. So we take them by reference. Fair enough. Then we have the start. It doesn't really return anything. All right. So what do we need now? Now we need some stuff like that. Then we need ND array async. Async is a very nice way to describe certain operations over one or more arrays. So in this case, what you do is first you gotta say the pattern. So we want an index and we want it to be, let's say, out row, out column. All right, and we want a mutable reference to that one. We want a mutable reference to that one. We want just a reference to that one. And finally a reference to that one. And that stuff actually has to be in brackets as well. So let's do it like this. In parentheses. And then we need the function to run in here. And let's see. I feel like we should have the correct syntax now, because I need a comma here probably. All right, there we go. Now everything should be a-okay. Let's maybe tab it in like that. And it's not indenting correctly, which is a bit annoying. It is indeed a bit annoying, but we can work with it. All right, and we need it. Well, so here we go. So the out position, let's put that stuff in a array here. So this is what this is where we want to write to, I suppose. And then we can say stencil start array 2. Interesting. So we have this function that just makes an array of size, like not an indie array, but just an array of size 2. So that's great. And what are we going to do here? We're going to say take the ith position and subtract stencil offset I. So let's remind ourselves what the stencil offset is inside of const. It's just 1, comma 1. All right. And the end is where you add it. Okay. Be this plus stencil offset I plus 1, but we're just going to make sure that we don't go outside of the array. I think that's what we have here. Indeed. Then there is a stencil range, and the stencil range is just from start to end. Interesting. Okay, so stencil start, stencil end. Okay. Fair enough. Compute the diffusion gradient for U and V. Let full U full V equal start start.u, but I have a reference here to U, so why can't I use that? It's gonna use that. U slice that stencil slice, which is, what is that? Ah, I forgot that one. So we have to have the slice here, and it's going to be in the array, the slice macro stencil range 0 dot clone stencil range 1 dot. Great. So we take a slice here. So it's like 3 by 3 area around this position, and the indexed iter zip that with basically the same like there. All right. Then we fold over that. Like this. All right, so what is happening here? In row, in column. Stencil U, stencil V, and all right. Let me put in this stuff. Just complaining about the syntax, some kind of syntax error. So don't see it right now. Why is there a comma here? It doesn't make any sense. It's also it should be like this. All right. Okay. I see. So these guys are actually numbers. That's why we need to say start u and start v. And does it have to be references? Does not. All right. Great stuff. So we need something in here, and it has to actually return the next accumulator. And row and column and stuff. Stencil u. All right, let's try to format it. It didn't really do much. And finally, uv square is u times v times v, okay. And du is fusion rate u times full u minus uv square plus ups the feed rate times this, and EV is probably diffusion rate V times full V plus UV square minus the feed rate plus the till rate times V. And then we actually write that stuff. U plus du times the delta t v and v. That should do it. Now we can try to run it. So let's go into the main function. Stuff we don't need. We don't need the float anymore. That's all right. So what we're going to do now, we're going to run this thing, but we are going to run it not with this function that does nothing, but with naive, let's say create naive dates. And all right. So, and it's not great, it's gray scope. Fair enough. And still it's complaining about that. Okay, so actually we need that end, and it's just going to run this function but with options.update options and start end. And again, this has to be actually by reference. All right, so let's go ahead and try to run that in release mode, but first let's get some help, because I don't necessarily want to run it on a huge image or anything like that. So while that is going, let's go into data and just remove these images. There you go. Okay. So we want to set R to, let's say, 200, C to 200. We don't necessarily want 1,000, maybe it's fine. This is fine. Let's just make it small. Let's do like this, cover run, release with R being 200 and C being 200. And let's see how fast it is. So it's reasonably fast, but it's doing a lot of iterations. And yeah, I will meet you back here when that is done. All right, so that's finished. Now, if we go ahead and look in the data folder, we got a bunch of images. And I also made this script here that runs FFmpeg and creates a video for us to look at. So we can go into data and then we can say, we run that, and it should create for us a video. And here's the video, which we can now look at and see the evolution. Let's go back to the start. So it starts out as a square and then it evolves with this very interesting pattern. Very, very interesting non-trivial pattern. And it's very mesmerizing to look at. Let's try to go a little bit ahead. So it ends up being this, like, I think, looks like it's kind of stable here at the end. Very weird, very organic look. All right, I kind of want to make a different kind of visualization. So let's go into UV and we'll make a new function like this that is write to, let's say, joined image, which will actually write both, but it'll maybe put them next to each other. So let's get rid of that one. And the image here will now have 2 times the, because then on the first, on the left side we'll write U, and on the right side we'll write a V. So great. If column is less than width, do one thing, otherwise we do another thing. So here we want, let's say U, why not? And here we want V. Format that. It doesn't like this because this is U32 and this is U size. So when I just do like that. Okay, great. So what we're going to do here in the main function is instead of do we really need the other ones? Maybe not. So why don't we get rid of them? Say file name, and it's going to be, we'll just call it UV, why not? Write to joined image. Don't need that anymore. That one we can throw away. There's no U in the end. And let's go ahead, go into the data folder, we're already there. Let's clear it out. And let's also remove that one. And then I'm going to run it again. And I will see you back here when we are done. So it didn't work because of something out of bounds. So we made a small mistake here. Let's see. It's because when we're in this branch, we actually need to say column SU size minus. Try that again. And it's running, and I will meet you back here when it's finished. Right, we're done. Let's see here, we are on the data. This one we need to modify. UV. We're gonna run it, and out will come something. Here is the video. Now we can see how it looks. It's kind of just mirroring each other, which is a little bit boring. So it is what it is. Let's not do this one. But all right, so that's how that looks. And that is our, this is the kind of algorithm that we want to optimize. when we go through these next steps. But that's going to be the next video. So until then,